Back to India's most comprehensive online learning platform, BYJU'S Exam Prep. This is Anil Sir, and in this session, hi Harshita, good evening. A very good evening to one and all. I welcome you all to this wonderful session in which we are going to again revise whatever we have learned in computer architecture and organization in a comprehensive manner. Anu Ajay, good to see you again. Yeah, all my students are coming back. Yep. Shall we start this session? On big S, I'm going to start this session. Once again, in today's session, hi Chitra. In this session, we are going to again revise whatever we have learned in the computer architecture and organization. Not just a recap, we are going to have a complete comprehensive idea for one more time. Okay, and this session, hi Anita, hi Krishna, hi Chitra. Yeah, in this session, the topic is addressing mode and applications. Okay, so without wasting any more time, let me take you people into the session straight away. For those people who don't know about myself, this is Anil Sir, and for the past 13 plus years, I've been in the GATE training. I taught everywhere in India, including Andaman and Nicobar and Srinagar. And for the past 5 years, I almost conducted many seminars in motivating the students towards their career and the post-graduation. Now, first and fundamental thing that in this session I just would like to start with. Let me tell you. See, in GATE 2023, for GATE 2023, we do have only some minimal time. This time must be productively utilized. This time must be potentially utilized. We should be able to exploit the time. Hi Sri Lakshmi, very good evening. We should be able to exploit the remaining time so that we should be able to get a rank in between. You know what I always target for. I want you people to see yourself in 1 to 100 ranks. For that, do not miss this session, which is coming on your way on 19th November live at 8 p.m. Here in this session, Mr. Abhinav Negi, who is the alumni of MTech IIT Delhi, who has got almost 10 plus years of experience, he is going to give you every idea, every tip and trick, every possible way. He is going to guide you and direct you in a proper way how you are going to see yourself as a topper, since we are having only some minimal time, right? So for that, don't miss this session and get the test series. If you did not get the test series from BYJU'S, get it right now, because simply it is just nothing but peanuts. With the affordable prices, you will be able to get the test series, because this is the time for all the test series, right? November, December and January, we should be able to focus on the test series. So get the test series if you didn't get it. And one more thing is, this is also the time for the mock test. This is also time for the mock test, right? From the 15th November to 22nd November. We are coming up with the mock test. The mock test is live from 15th November to 22nd November. Do not miss this opportunity and attempt this mock test. First of all, get registered right then. You'll be able to attempt the mock test. Right then, you will be able to see yourself where exactly you are positioned to crack the GATE exam. If there are any loose ends, you'll be able to cover it, because still we got almost 70 days left. So this mock test is very important. Don't miss this, which is coming live on your way from 15th November to 22nd November. Now then, today's session is all about what? The addressing modes. What do you mean by the addressing modes? Hello Sachinarayana sir, very good evening. Nice to see you in this session. Very good evening. First of all, in this session, we are going to understand various addressing modes and what are the different types of addressing modes. And we also are going to understand what are the different applications of these addressing modes. Okay, so let us start without wasting any more time. Now, first of all, why we require to have an addressing mode? First of all, what is the need of the addressing mode? What is the essence of an addressing mode in a computer system? Let me tell you, first of all, from the programmer's perspective and from the designer's perspective, these addressing modes can be seen in two different ways. From the designer's perspective and from the programmer's perspective. Let us say you are a programmer. Let us say there is one more guy who is a designer of a system. The way they look at the addressing mode is slightly different. When you ask the designer what exactly is this addressing mode, the designer will tell you that by using any addressing mode, we will be able to find out the actual location of the operand, where the operand is present for executing any instruction. We would be able to know. That is what the perspective of a designer. Now, at the same time, let us think from the perspective, from the point of view of a programmer. From the point of view of a programmer, these addressing modes are essential, pretty essential, because without these addressing modes, many of the programming language features will not get enabled at all, will simply be disabled. Without addressing mode, trust me, there cannot be any pointer. Without addressing mode, trust me, there is no array. Without addressing mode, trust me, nothing ever is gonna happen in the computer system. You can't even load your program into the main memory. This is the addressing mode that is going to support the essence of a program. If you are a programmer, you want to execute a program. Even if you want to load your program into the main memory, which is the fundamental route to execute the program, we require an addressing mode. So anyhow, the actual duty, Architanand, let us understand effective address. We talk at the core level, but at a programmer's level, when you use an addressing mode, that is going to enable a feature of a programming language. Got me? Yeah. Anyhow, from the designer's and programmer's perspective, if we blend them together, addressing mode is simply required. Addressing modes, many addressing modes must be supported by any processor in order to simply enable several features of the program, several features of the programming language, so that the program execution paradigm will be made very simple indeed. So that's it. Every instruction of a program has to operate on data. For example, when you want to perform addition instruction, this addition instruction requires some operands. Where the operands are present, the operands, we will be able to know what is their location by the addressing mode that is being followed by that particular instruction. The different ways in a source operand is denoted in an instruction are known as addressing modes. I will come to this. Used to specify the effective address of the operand. Yes, this is what, I mean, at the core, at the fundamental way to understand, the addressing mode is very simple. The addressing mode will tell you the exact location of the operand. What is the exact location? Exact location is called, in the other words, is called an effective address. What is an effective address? Effective address is the location of operand, either in the main memory or in the processor's register or anywhere. Effective address is the actual location of the operand. Okay, we'll be able to calculate effective address. I mean, effective address calculation will be different from addressing mode to addressing mode. An address at which the actual operand is present. This is what the effective address is all about. The number of addressing modes vary from CPU to CPU. Now understand something. Now understand something. Excuse me. Just a minute. Yeah, understand something which is very important. See, let us say we are talking about many processors, maybe 8086, maybe 8085, or i3, or i5, or i9. These are the processors, right? I guess these numbers or alphabets are going to give you some sense, right? These are all the processors. Maybe Qualcomm, Snapdragon. Any processor, what you name, it will have some addressing modes. It need to gonna support a few addressing modes, but the number of addressing modes that are being supported by a processor is different from the other processor. According to the need of any processor, according to the objective of any processor, the number of addressing modes will be identified and will be implemented. For an example, 8086, I guess around 15 to 20 addressing modes will get supported. Around 15 to 20 addressing modes will get supported by 8086. Similarly, 8085, around 15. i3, more addressing modes. i5, more addressing modes. i9, more addressing modes. It is just simply because the objective of any processor, why a processor is being used, what is the purpose of a processor. Some processors may be gaming processors. Some processors are just only for the program execution. Some processors wants to run 4K videos. Got me? So, different processors implement different number of addressing modes. Anyhow, let me directly take you people into, this is what I explained. Let me tell you. The addressing modes may be different from processor to processor, but what we're going to discuss as of now in this session is the standardized addressing modes, the standard addressing modes which are gonna get used by every processor. Every processor are gonna use only these addressing modes. But if some processor has more than the current addressing modes that I am discussing, those processors use some more addressing modes by only using these addressing modes. That means that the addressing modes what we are discussing are being customized and used appropriately in those processors. So let me start with all the addressing modes. There are, the standardized addressing modes are from 11 to 12. I'm going to list out all those addressing modes. First one is direct addressing mode, second one is indirect, third one is implied, immediate, register, register indirect, auto increment, auto decrement, relative addressing mode, base register addressing mode, and index register addressing mode. These are the addressing modes that I'm going to explain you right now. The first addressing mode that I'm going to take up is the direct addressing mode. Understand, before I take you people into the addressing mode, first of all, we need to understand everything from the perspective of a processor. For this, I'm going to take one processor which is single accumulator organization. Okay. You know what is already single accumulator organization, especially when you are following my classes very carefully. But anyhow, I will tell you, in a single accumulator organization, instruction will look like this: add followed by some memory address 450. Got me? In single accumulator organization, in the instruction, we got two things. One is opcode and the second one is operand. Somehow or the other, one operand will be specified. But in order to execute any instruction, in order to perform any operation, we require two operands, right? One operand will be specified within the instruction. The second operand will always be a processor's register, which is called accumulator. In the single accumulator organization, the second operand is always accumulator. That means that add 450 meaning this 450 will get added to accumulator and the accumulator will get updated. Now I will tell you in this same light, I will explain what is direct addressing mode. Direct addressing mode meaning within the instruction we have first thing which is called an opcode and the second thing which is called an address. Excuse me. Yeah, let me clear this. In the single direct addressing mode, instruction will look like this: add followed by one memory address 450. What is this 450? This 450 is not a direct value, rather it is a memory address. Harshita Anand? Yes. So now what exactly is going to happen during the execution of add 450? Simple. Accumulator will be added to accumulator plus memory of 450. So what is memory of 450? Taking this memory address, we will access the memory location 450. Of course, definitely there will be an address in the main memory, that is 450. In that 450th address of the main memory, we will have some data. That data, whatever it is, will get added to accumulator. Finally, the contents of the accumulator will get updated. Accumulator is equal to accumulator plus memory of 450. What Harshita Anand told is perfectly right. Okay. Now, indirect addressing mode. This is direct addressing mode. Now tell me, what is indirect addressing mode? Indirect addressing mode meaning, again, it is similar to direct addressing mode, but only the thing is, there are several things written on the screen, but just listen to me. Only the difference between direct addressing mode and indirect addressing mode is, of course, we have an opcode in the instruction followed by an address. But this address right now is an indirect addressing mode. That means that when you go to the specific location within the main memory, you are going to find out one more address. Earlier, when we in the direct addressing mode, when we went to this same location, when we went to the address that is specified in the instruction, we just ended up having an operand. But now, when you go to this address, you will find one more address. The content under this memory location is just nothing but one more address. Let us say at 450th location, I got 550. Now, 550 is not an operand, rather it is one more address within the main memory. Going to that 550, you will be able to get the operand. whatever the operand, maybe 600. You got me? Finally, what is the operation get performed? Accumulator is equal to accumulator plus m of, again m of 450. Am I right or not? I guess so. Yes. In the indirect addressing mode, the address part of the instruction is going to specify one address. When you go to that location in the main memory, you are going to find out one more address. That address is, in that address, we are going to find out the operand. The effective address is right now is 550, right? Let me go to the next one. Okay, so effective address is calculated as memory of address part of the instruction. Now, what is address part? This is the opcode part of the instruction followed by one address part of the instruction. This is add is an opcode. Every opcode is followed by one address in which we are going to find out one memory address. That memory address can either be direct or indirect, as we discussed. The next thing is implied addressing mode. What is an implied addressing mode? Stay focused carefully. Just a minute. Hello. చెప్పండి, నేను క్లాస్లో ఉన్నాను. ఎస్ మ్యామ్, నాకు 8:30 కాల్ చేయండి. In the implied addressing mode, what's going to happen? In the implied addressing mode, we do not have any separate address. We do not have any, what do we call, separate operand specified in the instruction. For an example, there are some instructions. Let us say there is one instruction called CLA. There is one more instruction called CLE. Okay, these instructions will not get supported by an external operand. If an instruction contains operand within itself, that comes under implied addressing mode. Look at CLA. What exactly is CLA? CLA stands for clear accumulator. CLA stands for clear accumulator. CLE stands for clear extended accumulator, in which we do not have any external operand. Got me? So no need to specify address in the instruction. Effective address is always accumulator or some processor's register. Okay, our effective address can also be at the stack pointer. Examples from the basic computer is equal to CLA, CME, clear the accumulator, complement the accumulator, INP. What is INP? INP stands for input. Input the data from the peripheral devices. Next one is immediate addressing mode. What do you mean by immediate addressing mode? Now, understand carefully. Earlier, there is an opcode. That opcode is provided by some address in the instruction. This address will fetch you the operand from the main memory, either in the case of a direct address or in the case of an indirect address, right? But here in the immediate addressing mode, what we are going to find out is, in the immediate addressing mode, this opcode will be followed by a direct value. This is the direct operand. This is the operand. This is not a memory address anymore. This is the only operand. That means that accumulator is equal to accumulator plus 450. Got me? So this 450, which is specified at the address part of the instruction, is the direct value. It is no more an address of the operand. So in immediate addressing mode, we got a direct operand specified within the instruction, right? Instead of specifying the address of the operand, operand itself is specified within the instruction. No need to specify address in the instruction because here we are specifying the direct value. However, operand itself needs to be specified, sometimes require more bits than the address. Let us say, understand carefully, an operand size in any computer system these days a minimum of 16 digits. Okay, because 16 digits are actually required to define an integer in a C program. What is the integer size? Integer size is equal to 16 bits. When you accommodate one digit for the mode, one digit for the size of the integer is equal to 2 power 15 minus 1. That means that we require 16 digits for the operand, but the address part may be even more lesser than the 15 digits. So, but anyhow, this immediate mode will make this instruction execution very faster. Why? Because in the immediate addressing mode, we are not going to the main memory, so the access to the main memory will be completely saved, because when we access the main memory, it is going to take a longer time. But in the immediate addressing mode, as the operand is already present within the instruction, we don't take much time to execute it. Okay. Next, register mode. What is the register mode? Simple. In addition to add the opcode, here the operand is neither an address nor an immediate value. Rather, one processor's register will be specified. That means that add R1 meaning accumulator is equal to accumulator plus R1. Let us say I have a instruction. Sorry, I do have a register. That register is register 1. The name of the register is register 1. The value is equal to 100. When the register 1 is an operand in this instruction, accumulator will be added to the contents of the register 1, and finally accumulator will get updated. This is what the register addressing mode. Next one is register indirect addressing mode. Register indirect addressing mode is similar to indirect addressing mode. Register indirect addressing mode also somewhat equal to the register mode, but only the thing is the register which is specified in the instruction now contains a memory address. Now let us say add R1. Earlier R1 contains the value, so accumulator will be added with the R1's contents only, but right now R1 holds a memory address. Let us say R1 is equal to 100. But is the 100 a value? No, 100 will not be value in a register indirect addressing mode. Rather, it is an address. So, going to the specific location of the main memory, we need to collect the operand. That means that accumulator is equal to accumulator plus M of R1. Okay. So, that is what the register indirect addressing mode. The next one is auto increment or auto decrement addressing mode. I will have to explain you this in a precise manner. Auto increment and auto decrement, first of all, these are based on the register indirect addressing mode. You got me? Auto increment or auto decrement, if you want to define in a processor, first of all, that processor must support register indirect addressing mode. Why? I will tell you. Auto increment, auto decrement, up to some extent is completely equal to the register indirect. I will tell you. Stay focused. Say, I have an instruction add R1. Of course, what is this? This is register indirect. We do have a processor's register specified within the instruction. Going to that specific register, we will collect the address because it is an register indirect addressing mode. When you go to that memory location, you will actually get the operand. Okay, this is the operand. This operand will be added to the accumulator. Accumulator is equal to accumulator plus M of R1 where operand is present. Clear? Now the thing is, the auto increment addressing mode or auto decrement addressing mode are strictly based on register indirect. Let us discuss about auto increment addressing mode. Auto increment addressing mode is exactly equal to the register indirect, except finally the contents of the register will be incremented. Right after you perform the operation, we will go back to the register that is specified within the instruction and increment the contents. That is, after performing this addition operation, going to the main memory, collecting the contents, adding to accumulator, instruction is completely executed. Right then, there is one more operation to be performed, that is going back to the register, and that register contents must be incremented. So, right after performing this operation, R1 contents will become 101. Okay, so clear. Let me clear this. Yeah. When the address on the register is used to access the main memory, the value in the register is incremented or decremented by 1 automatically. Similarly, auto decrement addressing mode. Let me explain you auto decrement addressing mode. Let us say add R1. Now, R1 also has a processor's register. let us go to R1. Now, the only difference between auto increment and auto decrement is, in the auto increment addressing mode, we will update the contents of the register 1 after performing the operation. So, whatever the value it is present in R1, it is the effective address, right? This is the address that takes us to the main memory. But in the auto decrement addressing mode, first of all, you need to go to R1, decrement the contents. 100 will be decremented to 99. This decremented value will be the effective address. The difference between auto increment and auto decrement. Stay focused. Once again, remember auto increment. Instruction is add R1. Okay, it is auto increment addressing mode. It will be denoted this way. Now go to R1. Okay, get the value, go to the main memory, access the contents, whatever the contents that are present there, maybe 500. These will get added to accumulator. Right after you perform this operation, for one final time, we need to go back to the register just to increment the contents. So when the register is getting updated after performing the operation, right? But in the auto decrement addressing mode, there is a slight variation. What is that? Same add R1. Auto decrement addressing mode will be specified this way. Now, initially we need to go to R1 and the contents is equal to 100. But now, first you need to decrement the contents, that is 100 will be decremented to 99, and now this is the effective address. So go to 99, get the content, whatever the operand, that operand must be added to accumulator. Got me? Now the thing is, we will go to the next addressing mode, relative addressing mode. What is the relative addressing mode? Stay focused. I will explain you in the simplest way which is possible. See, in the relative addressing mode, understand carefully. Understand carefully. Here itself, I also will explain you the application of the relative addressing mode here now itself. This is very important to understand. Stay focused and be with me. Let us say there is an instruction 9. Okay. What is the program counter value for this? If it is 9, the program counter value is equal to 10. Let us say I am following word addressing convention, not byte addressing. Anyhow, I am not talking about this. Let us say my program counter value is equal to 10. Okay. Now the thing is, I want to execute a call instruction. Okay. When I want to perform a call instruction, let us understand. I want to go to 20th location. I want to go to 20th location. How can I go to the 20th location? I will use the program counter value wisely. So what I will do is, I will put a value here. Okay. When the value is clubbed with the program counter value, I will be taken to the target address. What is the target address? Where I have to branch. Once again, in the 9th instruction, I have a call instruction. What is the call instruction? Call instruction is going to take me to a branch address. What is the branch address? Subroutine address. What is the subroutine address? The intention behind I'm executing this call instruction is I want to go to 20th address, because right from the 20th address there is the procedure, there is the subroutine, whatever you call. I want to execute this subroutine. But how can I go there? How can I directly go to 20? Simple. What I will do is I will put a value here. When this value is added to the program counter value, I will go to that specific location. Now you can clearly understand. When you use the relative addressing mode, it is possible to load your program anywhere in the main memory. Let us say this is your program. You did not load your program into the main memory yet. In your program, from the 9th instruction to the 20th instruction, you need to make a branch. Did you get it? Simply you can't say 20 here. When you say 20, what will happen? When this program loads into the main memory, let us say your program is loaded from 100th location. In the 100th location, your program has been loaded. Now, in 109, you are making a call. In 109, where you have to call? Let us say if you implement directly call 20, this call 20 is going to take you to the 20th address at which your program is not present. Clear? See, this 20, you have to branch to the 20th instruction, because this 20th instruction that you have to execute is the 20th instruction of your program. But when your program is loading in the main memory, you don't know whether your program is loading from 0th instruction, 0th address or some address. Definitely your program will not get loaded from 0th address. If your program is loading from the 0th address, it may be appropriately calling 20th instruction. But let us say your program is starting from 100, 100 address. At that time, if you perform call 20, what will happen? Immediately, the computer system is going to trigger your program out. Immediately, your computer system is going to terminate your program. You are allowed, any program is allowed to access only its address space, its memory space. So, by abiding to that rule, I need to wisely make a call to the 20th location of my program. So, what I will do is, I will use a value here. Let me erase this. I will use a value. When I say 10, let us say your program is loaded from 100. Now you can say call 10 only. But what will happen at that time when you say call 10 and relative addressing mode is used? This 10 will be added to 110, which is the program counter value. 110 plus 10 is equal to 120, where exactly you need to branch, because you are required to branch to the 20th instruction of your program. When your program stored at 100th location, from the 100th location, your effective address will be equal to 120. Got me? So this is the very reason why we will use the relative addressing mode to support a relocation of the program. This relative addressing mode supports relocation of the program. How the effective address will get calculated? Let me erase all these things. The effective address of this will get calculated by a simple logic, that is program counter plus address field of the instruction. Now this is not 473. Let us say 910. Here let us say call followed by 10. This is the program counter value. Program counter value will be added to the value which is specified at the address field of the instruction. 10 plus 10 is equal to 20. Effective address will be equal to 20. I hope I made my point clear. So in the relative addressing mode, effective address will be calculated as, yes, program counter plus the address value in the instruction. Program counter plus address value, I would say address field of the instruction. Simple. For the branches. Next one is base register addressing mode. What exactly is this base register addressing mode? When you talk about the base register addressing mode, first of all, you must understand every computer system will be supported by two registers. One is base register and one more is index register. There are two registers supported by every system. Names may be different. One register may be called as a base register, one register may be called as an index register. Simple. How the effective address will get calculated? There is an instruction. That instruction is add again 450. This is the value present at the address field of the instruction. Now in the base register addressing mode, effective address will be calculated as the value which is present in the address field of the instruction, I would say AF5, the value which is present at the address field of the instruction, which is equal to 450, plus the contents of the base register. This 450 will be added to the contents of the base register. So that is equal to, if the base register value is equal to 100, 100 plus 450, which is equal to 550 is the effective address. So going to the 550th location of the main memory, you will get the operand, whatever it is. This operand will be added to accumulator. So what is the effective address? Effective address is equal to address field of the instruction plus contents of the base register. Now understand. What is index register? Index register also is the similar manner. Only the thing is, effective address now is a addition of value that is present in the address field of the instruction plus Rather than adding the contents of the base register, we are now going to add the contents of the index register to the address field of the instruction, right? Now let us say the instruction is add 450. Now let us say I do have an index register in the system. That index register value is 50. Now effective address is equal to 450 plus 50 is equal to 500, where the operand is present in the main memory. That is the difference between base register addressing mode and index register addressing mode. Okay. Effective address is equal to contents of the index register plus address field of the instruction. Now, within this example, we are going to completely summarize the total addressing modes. Harshita Anand, yes, exactly. Program counter plus index register value. Directly in index register, Harshita Anand, index register you cannot put in the braces. Excuse me. No. Program counter cannot be added. It is, understand, effective address in the index register addressing mode is equal to address field of the instruction plus index register contents, right? Correct your answer. You just need to correct your answer. Okay. Now with this example, we completely will understand. Let us say there is an instruction. There is an instruction add 500. In the direct addressing mode, what will be added to accumulator? Go to 500 location. In the 500 location, there is 800, right? Yes or no? This value will get added to accumulator. This value will get added to accumulator. Let me clear this. In the immediate operand, 500 is the direct value. Let us say add 500. If it is in the immediate addressing mode, the value 500 itself will get added to accumulator, right? The value 500 itself, it is going to get added to the accumulator. Accumulator is equal to accumulator plus 500 is the meaning of immediate addressing mode. In the indirect addressing mode, what will happen? Let us have a look at. Add 500. Now go to 500. When you go to 500, you found some content. This content is now not an operand. Rather, it is an address. Going to the address, you are going to get the actual value. That means that in the immediate addressing mode, you are required to access the main memory for twice to fetch the operand. One for the address, one more is for the one more address, because the address contains one more address. That means that for the operand, you need to access the main memory for twice. Now relative addressing mode. In the relative addressing mode, what will happen? First of all, let me erase the contents. This 500 will be added to 201, because in the effective address will be calculated as effective address is equal to the value which is present in the address field of the instruction. This is the address field of the instruction. AF5, address field of the instruction contents plus program counter value. What is address field of the instruction? 500. What is program counter value? 201. When you add both 500 plus 201, you will get 701. In 701, whatever the content, that will be added to the accumulator. Go to relative. Effective address is equal to 701, as I told you. Accumulator is equal to accumulator plus memory of 701. Got me? Now, let us go to the next addressing mode. Indexed addressing mode. What is indexed addressing mode? You can see there is index register. XR is the index register. Now, this 500 will be added to index register contents. So 500 plus 100 is equal to 600. Effective address will be equal to address field of the instruction, that is equal to 500 plus index register content, that is equal to 100. That is equal to a total 600. Okay. So indexed addressing mode, 600 is the effective address. Accumulator is equal to accumulator plus memory of 600 is equal to, when you go to 600, there is the content, this 900 will be added. Okay. And the next thing is register addressing mode. In the register addressing mode, I don't need to specify anything, because this won't be the instruction, because within the instruction, in addition to the opcode, we will have a processor's register R1. Yes or no? In the register addressing mode, the instruction may be like add R1. If it is R1, there is no effective address at all. R1 produces the memory operand. that R1 will get added to the accumulator itself directly. In the register indirect addressing mode, what's going to happen? See, the contents of register R1, let us say R1 is equal to 399. Okay, 399. Now we'll have one more address. Did you get it? Now 399 is not a value. Going to 399, we got one more address. Where is 450? Do we have 450 here? No. Let us say 450 is the actual effective address. So in 450, let us say the content is equal to 1020. This 1020 must be added to accumulator. So now let us say add R1. R1 is a register which contains one more address. When you go to that register, you will get one more address. 399 is the effective address. When you go to that address, you will collect the operand. Sorry, you will collect one more address. Okay, that address will have the actual operand. The next thing is auto increment. What will happen? Right after you perform the operation, the contents will become 400. In the auto decrement, before you perform the operation, the content will become 398, where 398 is the effective address of the operand. Now, after understand carefully. These are all the standardized addressing modes. Go and look at all the addressing modes of any processor. All those addressing modes, the additional addressing modes that are supported by those processors are the customized addressing modes, but base is only these addressing modes. Clear? Base is only these addressing modes. Harshita Anand, you are perfect. That is only for the loops. Okay. Now, let me give you the application of each addressing mode. Stay focused. Direct addressing mode is for declaring variables. Direct addressing mode is for declaring variables. Immediate addressing mode is for declaring constants. If you want to be supported by variables and constants, rather the programming features, variables and constants must be supported inside of the processor. The processor must be able to support direct addressing mode and immediate addressing mode. Next thing is the indirect addressing mode. If the processor supports indirect addressing mode, pointers will be supported. Let me tell you, without indirect addressing mode, there won't be any relative addressing mode, index addressing mode, register indirect, auto increment, auto decrement. Be sensible. All these relative, indexed, register indirect, auto increment, auto decrement, all are actually based from the indirect addressing mode only, right? Because relative addressing mode, some address will be added to some other address. If a location contains an address, what does it mean? It's just nothing but a pointer, right? I hope you got my point. If you cannot support indirect addressing mode, no more subsequent addressing modes are being satisfied. No more subsequent addressing modes can be supported by the processor, can be implemented within the processor. Except register addressing mode, none of the other addressing modes can be supported by the processor if that processor doesn't support indirect addressing mode. Indirect addressing mode is the base of wide variety of the addressing mode, because the concept of the pointers will exactly start from indirect addressing mode, right? Similarly, relative addressing mode is for program relocation. Indexed addressing mode. What is indexed addressing mode? Index register addressing mode or index addressing mode is for array declaration. Indexed, Harshitanand is told, right? Array declaration is correct. And then register indirect. Register indirect is a base for auto increment, auto decrement, and these two are for the loops. And there is a register addressing mode. The register addressing mode is for updating the variable. If you ever want to update any variable, stay focused. Be with me. I want to perform A++. How A++ is going to get performed? Understand, A is the memory location. There is no ever way you can perform A++ in the main memory. Main memory is the place where the contents will get stored. Content will not get updated. For that, what I need to do is, first of all, I need to send this A to a processor's register. This processor's register must be updated accordingly. right after the updation, the updated value must be reflected back to the A. So if you want to update any variable, you must be supported by the, what do you call, register addressing mode. Got me? So these are the applications. And one more thing is, auto increment and auto decrement are for the loops. Base register addressing mode. Base register addressing mode is not given. Base register and relative addressing mode. Both addressing mode are for the program relocation. Relative, program relocation. Base register, program relocation. I hope I made my point very, very clear indeed. Okay. So the base register addressing mode is like, program relocation. Purpose of the addressing mode, once again, direct addressing mode is for variable, indirect addressing mode is for pointers, implied addressing mode. Understand, there is no specific use, there is no specific feature will get enabled by the implied addressing mode. This implied addressing mode is a system reserved addressing mode. And this implied addressing mode is just to update the accumulator. Anywhere in any processor, accumulator must be implicitly updated. In order to update the accumulator, we will use implied addressing mode. Immediate addressing mode is for constants. Register mode is for updating variables. Register indirect addressing mode is just a base for auto increment or auto decrement addressing mode. Auto increment or auto decrement are only for the loops. Relative addressing mode, program relocation. Base register addressing mode, program relocation. Index register addressing mode, as I already told you, it is for the arrays. I hope I made my point very clear here, with which we have come to an end of this session. Once again, absolutely. In order to remind you for one more time, you have one important session, especially if you're GATE aspirant 2023 or 2024, coming in your way live, 19th November at 8 p.m. Do not miss this session ever. This 8 p.m. is a very important time on 19th November, and this is going to taken by Abhinav Negi, who's the alumni of famous IIT Delhi, and he's a 10 plus years of experience. He's going to give you every idea what are the different tips and tricks in order to crack the GATE exam to be a topper. Okay, so that's it from the session. Please do like and share the session and subscribe to this channel if you haven't already yet. So with this, Anil Prasad Sorumpudi is going to sign off unless you do have any follow-up doubts on this session. Do you have any doubts? And we take a final good night. That's it from this session. Process synchronization session. Really, thank you so much, Chitra. Thank you so much. I hope. I really, I'm happy to know that process synchronization session helped you a lot, and thank you so much for stating this awesome. Yeah, that's it from the session. Thank you so much.